All right, today we're going to write and apply power functions, which is just a little bit different from what we did yesterday with exponential functions. Power functions look one little bit different. Here's what the difference is. Power function has the form y equals ax to the b power. Remember yesterday with an exponential function, the x was the exponent and the x and the b switched places today. Yesterday the x was the exponent, the b was a constant down here, and now they switch. So that's the main difference. All right. First thing, write a power function y equals ax to the b power. As graph passes through those 2 points. So what I'm going to do, they pass through the points because they work, obviously, like always. So I'm going to plug them in right there. So I'm going to put the 2 here. For the y, I'm going to put the 3 for the x, b power. Do the same thing with the other point. Put the 9 for the y. Put the 6 for the x. And I'm going to solve this one, which means a is going to be 2 over 3 to the b power. And the same thing I did yesterday, I'm going to plug that into my other equation over here for the a. So I'm going to say 9 equals 2 over 3 to the b times 6 to the b. And all that is I plugged what I knew from a from the first equation into the second one. If I multiply this out, these 3 goes into 6 2 times, so I get 2 times 2 to the b power. I'm going to divide both sides by that 2. So I get 2 to the b equals 4.5. Now I cannot find the same base there, so I'm going to do log or natural log of both sides. That's your choice. You may want to do log base 2, because if you do base 2, what's going to happen is it's going to cancel that left-hand side. So over here, I just get the b. And over here, I can go ahead and this left-hand side, I can punch in, I can do change of base formula. I can just do log 4.5 divided by log 2. And when I do that, I got 2.17. So there's my b. So I know what my b is. So to find my a, I'm just going to plug it back in right back up here. So we get 2 equals a times 3 to the 2.17 power. So a is going to equal whatever, 2 over 3.3 times 3 to the 2.17 power. Gosh, I'm having a hard time. Work that out, and I get a is 0.184. So there's my a, there's my b, my final function. Let me change colors here so you can find it. It's got worse stuff all over the place. It's going to be y equals 0.184 times x to the 2.17 power. And there it is. All right. So same thing as yesterday, except their b and the x have switched. Okay, transforming power data. So if they give you a set of data pairs, and you think it might be a power, remember power curve looks like that. You think it may be, here's what you can do. You can do natural log of the x's and natural log of the y's, graph them, should find a line like yesterday. Yesterday, all we did was natural log of the y. Today, natural log of x and natural log of the y. Should be linear. If it's linear or makes a line, we know we can do a power model. Let's look at a big one here. It says a table at the right shows a typical wingspans and a typical weights in several types of birds. Draw a scatter plot of the data pairs natural log x, natural log y, and see if a power function is a good fit, and then find the power model, assuming it is a good fit. So what I did, I took these numbers in this column and did natural log of those. Took the number in this column, did a natural log of those, and made a new table. So those are the natural log of each of those numbers. I went to my calculator, to be honest with you, and did scatter plot and graphed those numbers, and that's what it looked like, which is very close to a straight line. Because it's so close to being linear, I can now do a power model. And the way I'm going to do that is I'm going to do my point slope form. I'm going to use this last point just because I have a good reason. So I found the slope first. And you pick 2 points to find the slope of this line. I found the slope was about 2.5. So that's what I'm going to use. So I'm going to set this up. I'm going to go natural log y minus 2.774 equals the slope, which would end up being like 2.5, natural log x minus a 2.128. I'm going to save a little bit of time here. I'm going to distribute the 2.5 and move that 2.774 over. So I'm going to get this 2.5 natural log x minus 2.546. All right, so I've got all kinds of stuff over here. So I'm going to rewrite this a little bit and put the, remember, if there's a number in the front of the natural log, it's really the exponent on the number, so I'm going to change it to the exponent right there, minus 2.546. And then to get rid of the natural log, this is going to be kind of crazy here. Stay with me. I'm going to actually raise each side to the e power. I'm going to do e to the natural log y equals e to this whole side, 2.5 minus 2.546. And the reason I did that is because they have the same base. Over here, I'm just going to get a y. Over here on the right-hand side, all I'm going to get is my e to the negative 2.546, because there's really two e's over here since it's subtraction, times e to the x to the 2.5 power. So what that gives me is, well, if I just punched both those numbers in my calculator, I get this. If I punch this, I get 0.0784 times x to the 2.5 power. And right, guys, right there, that's my exponential, or my power model right there. Those two steps right there are a little bit unusual. If you're stuck with natural log, the way you would work out a natural log is you would do the natural log. But if you need to get rid of one, you would do e on both sides to cancel out your natural log. And then over here, what I did here when I got to this step right here, that has a natural log, that has an e with two things in the exponent, so I broke the e up into two different exponents with multiplication, because when you multiply, you add exponents. And then I just punched this one straight in my calculator. This one I just brought down. There's my function. And we'll work on that again tomorrow. Again, this is one of those videos like yesterday's, to where I don't expect you to get everything from the video, just a good head start. Let me get you through it in class tomorrow. All right, good news. Your TI-84 does this just like it did yesterday. So here's the steps we're going to do. We're going to put the data pairs into L1 and L2. And when I say data pairs, we're going to actually do the natural log of each one. Natural log of x, natural log of y. We're going to go to stat, we're going to go to calc, we're going to go to power reg, and it's going to tell me this right here. It's going to tell me what my a is and what my b is. So I can just write my function like this. I can just go like y equals 0.04 times x to the 2.87 power. It tells you exactly how to write it and everything right there. So the calculator's a great friend. Make sure you have one with you when you come into class tomorrow. It will help you so much. And again, one more time, I don't expect you to have this mastered watching the video, but by the time you walk out the door tomorrow, I want you to feel pretty good about it. It takes both these days, so hang in there. See you tomorrow.